Jignasa student study project on impacts caused by effluent from Raichur thermal power plant on Krishna River basin by Hanmantu Pravalika Firdos, BB Sara Anusha Raviteja under the guidance of E. Narayan Gaud Sir, Department of Physics, SCNM GDC, Narayanpet. Contents: number 1, introduction. Number 2, review of literature. Number 3, material and methods. Number 4, results and discussion. Number 5, summary and conclusion. Number 6, reference. We next continue the Pravalika.
This is Pravalika from second year MPC. Introduction. In the power plants, huge amount of water is used for several different processes which is then discharged as a process waste. The effluents from Raichur thermal power plant alters the physical, chemical and heavy metal parameters of Krishna river. Thus, it causes harmful effects on human life and aquatic life. Hence, river water is not fit for drinking, bathing, fisheries and irrigation purposes. The present study aimed at determining physical-chemical parameters and heavy metals of the effluent at outlet of bottom ash pond and disposal point in Krishna river. Thus, it evaluates the effluent impacts on Krishna river. Objective: to study the temperature of water sample in different months, to study the pH of water samples in different months, to study the turbidity of water samples in different months, to study the COD of water samples in different months. Review of literature. Union of Concerned Scientists and et al. Samir Kumar, Dhruva Katoria and Dhruva Sehag and et al. Muhammad Ishan Munawar and et al. Duke Health News and et al. Methodology. The study has been conducted to determine the impacts caused by effluents discharged from Raichur thermal power station on Krishna river basin. Data obtained could be helpful in defining pollution extent in the Krishna river. Thus, the samples are collected during the period from August 2022 to December 2022, twice in a month. Sample collection. The samples were collected to study the physical-chemical parameters and heavy metals in the slurry samples at outlet, downstream and upstream point and at disposal point in the river. By the method of graph sampling, the samples are collected periodically. The wastewater samples collected in jerry cans of 1 liter capacity. Ensure that no floating materials are present at sampling stations. The details of samples are labeled and the samples are kept in cold room. Instrumentation of various parameters. The temperature is calculated by thermometer and pH is calculated by pH meter, and turbidity of water is calculated by turbidity meter, and COD of water is calculated by COD digester. The next will be continued by Firdos.
This is Firdos Fatima from MPC second grade. 6. Result and discussion. Temperature. Temperature of the sample is fluctuating in the range of 26 degrees Celsius to 44 degrees Celsius during the study period. It shows the temperature is highest in the month of October and is in the month of December. The permissible limit of temperature is 40 degrees Celsius as per the BS and CPCB frame standard. The variation of temperature from slurry sample may cause due to temperature which cold is burned and addition of warm water by various processes. It is along with the slurry samples which alter the temperature of the sample. Thus, the temperature is important for its effect on chemical reaction rate, aquatic life and suitability of water for beneficial uses. Variation of temperature of samples in different months. We collected 4 samples in different months. The highest temperature is to be observed in the month of October and is in the month of December. pH. The pH of sample is to be observed in the range of 6.98 to 8.89. The permissible limit of pH according to the standard is 5.5 to 9.0, which is within the safe limit. The variation of pH depends on temperature of slurry waste, and it is well known that pH decreases with increasing temperature. Thus, with increasing temperature, the variation may cause due to addition of condenser water or warm water. It releases along with the slurry waste. The pH of all sample point is to be found within the safe limit in all months. As per BS and CPCB for standard during the study period, the increased level of pH from effluent deposed into river may cause adverse effect on river water, and it affects the rate of biological reaction survival for various aquatic life. Variation of pH of samples in different months. We collected 4 samples in different months. The highest pH is to be observed in the month of December and is in the month of October. The next will be continued by BB Sara.
I am BB Sara, final year MPC student. My topic is turbidity. The turbidity of sample during the study is to be observed between the 2 NTU to 125 NTU. The maximum turbidity is observed 125 NTU in the month of October at sample station, and for minimum is 4 NTU in the month of December at sample point. For the permissible limits of turbidity 1 to 5 NTU according to point 4. The permissible limits of turbidity turbidity for surface water quality. Hence, it is exceeded at all sample station. The reason may be surely waste content more solids of ash content. Thus river water is not fit drinking, bathing, fisheries and river and irrigation purpose. More turbid water will reduce the penetration of sunlight, the river and reduction of DO level, which is harmful to aquatic life and also spoil aesthetic view of river. Next. Variation of turbidity of sample in different months. We are collected for sample in 5 different months. The maximum turbidity 2 NTU to 125 NTU in the month of October. The minimum turbidity the minimum turbidity is 4 NTU to NTU in the month of December. Next, continue by Anusha.
This is Anusha, degree final year MPC. COD. The variation of the COD into will found in the range of 21.30 mg per liter to 117.60 mg per liter. The prescribed limit of COD is 120 to 250 mg per liter by BIS and CPCP inclined standards, and COD is within the safe limits at all sample stations. The variation may be case when slurry waste in the dispensed into a river undergoes chemical reaction. Further into resistance the variation, thus in pumps in inorganic substation like acids, alkalis and quinols, etc. But these are insoluble states in slurry waste, thus it shows minimum COD in sample station 4 at all months. Verification of the COD sample in different months. We are collected the 4 samples in 5 different months. Highest COD water in month of November, least COD water in month of September. Next will be continued the BB sir.
Conclusion. The variation temperature is observed at all sampling stations. The reason may be discharge of warm water from descender cooling and also by atmospheric condition. Hence, it is cases the variation of pH during the study period at all sampling station. It is well known that pH decrease in increased temperature, the turbidity of samples exceeded the permissible limits may be increased to the west, thus is pollutes the river water quality. The COD exceeded due to the presence of inorganic substance as per surface water. Inference with inorganic salt and chemical thus increase heavy metal concentration in the river water. The studies concluded the quality of river water is polluted due to the influent from power plant. Hence the influent needed primary treatment before it discharged into the river. Next, continued by Firdaus.
References: S. Mulakamdi, P. Isha Khadikar, R. R. Srivastava et al., Manju Sutta, Praveen Agarwal et al., Shikha Srivastava, Lekhika Srivastava, Akanksha Singh et al., Sandhya Sonewane, et al. Next will be continued.
These are photos we captured thermal the Raichur thermal station, thermal power plant near Krishna River base. Thank you, Head of the Department of Physics.
Banji.